akan awal lagi. Baru bangun nih. So I think we have 60 people already. Okay. Yeah, around 60 people. So we can start lah. Let me off my camera so that dia tidak ada banyak delay lah. Do you have any question before we start? Okay, so this is lecture number 7 sudah. So we have lecture number 7, 8, 9, 10. Okay. Now is considered week 9 kah? Oh, week 8 kah? No, week 9. Okay, this is another session in which we look into the document properties and some of the calculation that we may need in order to process the document. So we call it languages and properties of the document. So this is lecture number 7. So basically we will discuss about metadata. Okay, metadata is the data about the data that we have in our database. We also look at the format of the document. This is important because sometimes we want to write a program that will extract the information from the document. So we need to know what is the format of the document that we are reading. We also look at the text properties, some of the calculations, some of the theory found earlier that can be used to assist us to process the document with more efficiency. And lastly, we look at the pre-processing process that need to be done before we before we classify or before we perform the text similarity for the document. So as you know, the document is considered as a single unit of information. So of course it has a syntax and a structure. Syntax referring to the structure or the format of the document. Similar to your programming languages, when you first started to learn programming, you learn about the syntax and the semantic. Syntax refer to the grammar of your program or the structure of your program, and the semantic referring to the logic of your program or the meaning of your program. Okay. So of course in the document also we has syntax and also semantic. So semantic referring to any logic or any meaning that we want to express in the document. Okay. So the document may also have different presentation style. So it depends on the author of the document. So the presentation style given by its syntax and structure always related to a specific application. For example, in medical domain compared to in engineering domain, we have different presentation style. Okay. So in short, the document syntax expresses the structure, the format of your document, and also it expresses the style of the presentation of the document, and at the same time express the meaning, the logic behind the document that you have. Okay? So for example, like this, the document syntax will express these three: presentation style, the structure, and also the semantic. So one or more of element might be implicit or given together or combined together. Okay. For the document style, it defines how a document is visualized or printed. So, for example, if you look at this diagram, it tells you the chapter and also the chapter name, and also the introduction may have different font size or font style. So the document style also can be embedded in a document. Embedded means you pre-program the documents in such a way that it will give you the different document style. Okay? For example, we have this LaTeX. Okay, this is a technical editor application in which this is good for scientific document. Okay, this is some of the example of the LaTeX. For example, like this in the textwork editor, we specify the section, we specify the label of the section, we specify the paragraph, we specify where do we cite the reference. This is the citation also. Okay. So this is like you writing an essay at the same time you're doing programming, because we wanted to say this is the section, this is the label, and so on. And this is the output that we get. So depending on the style that we use, the section name will be printed differently. And of course, the label you cannot see. You just say the name of this section is introduction. So if you want to refer to this, it will be referred as section introduction or section 1. Okay. And also we have a few citations like this. So these are extracted from the list of reference that we have. So this is the first one, 11, and this is the number 10. So it depends on the list of reference that you have. It will tell you the number of reference. Okay, the reference number. This is 10, 11, and so on. So this is an example in which the LaTeX use the what we call the command in order to tell how it should be visualized or presented on the screen. Queries in search engine can be considered as short pieces of text, so different from normal text. example, we could have a short piece of text or maybe a single one, and we could have one word that has two meanings. So the semantic often ambiguous due to polysemy, in which we have one word that can refer to many things, coexistence of many possible meaning. Okay, for instance, bank could refer to bank of river or bank account or banking. Okay, so this is one of the issue when we want to look at the query for the search engine. So this is not a simple task to infer user intent behind a query, because we have to look at the full sentence or the full query. Okay, so the keyword may be bank, but we also have to look at the other word like river and account in order to know which domain they are referring to, which context they are referring to. Okay, so that is the format, semantic, and the presentation style. Okay, so now let's take a look at the metadata. So metadata is the data about the data that we have. So information about the data that we store. So example, in the database, names of relation, names of tables, and also attribute constitute the metadata, which means that we have to know for every column or for every field, for every attribute we have to know what is the data type, what is the range, what is the meaning of the column, and so on. Compared to the text document, in text document we store different type of data. So it includes author of the text, date of publication, source of publication, the length of document, the topic or content of the text. So two different type of metadata. So this is just the example. So metadata is the data about the data that we store in our storage. A long time ago, we used this, what we call a catalog card, in which we use this one to store information about the document. So we have call number, we have the title, we have the other title, we have the holding library, we have the many things. So all of these are very useful for librarian, where to locate and what type of document we have, what is the content, what is the category, what is the standard book number, and so on. So when we refer to semantic metadata, okay, so this is the example of metadata of a document, information about the document that we have. For the semantic metadata, it characterizes the subject matter within that document content. So normally we are referring to the concept or the idea or the content of the document. Okay? So normally this document is associated with a wide number of documents. So we can link one book or one document to the other document. Okay? So it refers to the subject matter. So in other words, we are talking about the idea, or we are talking about the content. Okay? or we're talking about the concept, and so on. So this is the content or the idea or the concept that summarize from the document. And in the state, we have this machine readable cataloging record. So this is one of the most common format for library record. So it looks like this. So they keep all the information about a document, the main author, the title, what edition we have, description, and also note, reference, and so on. Okay. So these are the sample of MARC, machine readable cataloging record. Okay. So any questions so far? So the three main things that we have to look at, that syntax can be used to express the structure and also the presentation style and also the semantic of the document that we have. So what we have in front here is one of the tools that we use to describe a document. Okay? And since the establishment of the internet, we also have many documents on the web. So how do we actually store the information about a web page? So metadata in a web document, this is the data about the data in a web document. We need to keep the information. We need to add metadata information to web pages because we want to do cataloging and content rating. We also want to look at who own that page, and also that this can be used in the application of electronic commerce for the business e-commerce. Okay. But how do we actually store metadata information about the web page? So we use this resource description framework, RDF, very well-known tools on how do we keep the metadata information of the web page. So this is a new standard for web metadata. Okay. So it allows describing the web resources to facilitate automated processing, especially in searching the document. Okay. Okay. RDF does not assume any particular application or semantic domain, but it consists a description of nodes and attached attribute value. So these are the value that will be used in order to describe the web page. So we have a node, which means that we have a variable that we can store the value of that attribute. Okay? For example, a web page can be identified using URI or URL and URN. So URI referring to uniform resource identifier, and URL referring to uniform resource locator, and last one is name. So what are the differences between them? This is how do we differentiate them. The URI cover everything from HTTP or HTTPS, sometimes we have S, up to the end of the address that we have. So this is what we call uniform resource identifier. But sometimes we have this symbol, okay, the hash key. The hash key will separate the location and also the name of the resources. So this is if we only start from this up to this area, so this is the uniform resource name. Okay, but up until here from the HTTP or HTTPS, that is the URL. Okay, so we can use this uniform resource identifier as the identifier of that particular web page. And we could extract the author from the web page that we have. Okay. So the RDF is a model for representing name properties and property values. So for example, the object, it consists of object types, the resource, the properties, and the statement. Okay, let me show you the example here. So normally we use the three-tuple representation. We have the predicate, we have the subject, and we have the object. Okay. So the predicate normally used to show the relationship between the subject and the object. For example, if we have this, the author of this web page is this one. Okay, so this is the relation between these two. So this is the author of this subject. Okay, so the resource is this one, and the relation is the author or the predicate, and this is the author of me. Okay, there are one specific topic that discuss in depth about this. They call it semantic web. So there is another course called Semantic Web in which we learn how to add metadata to web page. So this is the example on how do we get the or keep the metadata of the web page. We use predicate, subject, and object. Okay. Okay. So far we have covered metadata and also the document format. So now we look into the text properties, but before we can go to text properties, we look at the information theory. So information theory is a very well-known theory in which it is used to measure the distance between, it compute how much information that a word can carry. We will tell you later on. Okay. So we look at the information theory. The issue that we wanted to address here is that how much information that a certain word can carry. Okay. So this is the issue that we want to address. It is difficult to formally capture how much information is there in a given word. For example, we take this one compared to this one. Okay, so how much information that captured by this compared to this, given in a closed world, given that we have this sentence. So there must be a way on how we can tell the difficult word is more important compared to is, because it carry more information. But how do we know? There should be a way on how do we compute how much information that a certain would carry. Okay, so Like this one, we say, for example, a text where one symbol appear almost all the time does not convey much information. So definitely this one carry less information or no information. Okay, so information theory define a special concept called entropy to capture information content, to define how much information has been captured. Okay, so what is the entropy? So we will look into this. I believe you have seen this one before, but we never discussed about the theoretical fact about entropy. So let's take a look at this one. So the entropy of a whole text, so this is one word lah. Okay, so this is one word, is given by the probability of, this is the summation from 1 to n, and we take the average. So this is the probability of this alphabet occur in the text. So we take 1 over the probability of the symbol ti occur in the text, and we take log base 2. So this is the formula that we have. Okay, how do we apply this? Okay, let's suppose we have a closed model. A closed model means we are only looking at this sentence. Okay, so we have University Malaysia Sabah. Okay, so remember that we wanted to apply this formula. So this formula, we need to compute the probability of that certain symbol occur in the text. So if we use that one, let me erase first. Okay, so in here, how many spaces we have? So this is 3, 3, 4. This is 10, and this is 9, and 3, 3, 4. This is 8. This is 5. Okay. This is number of symbol. So altogether we have 23. Okay. So when we look at the U occur only once. So 1 over 23. And when we look at N, symbol N, 1 over 23. I, we have 1, 2, 3, 4. So 4 over 23 and so on. So we compute semua lah. Okay. So the entropy of a whole text T. So let's suppose we only take this university. Okay. So we apply this. Okay. So basically for this one, we have 1 over 10 because we have 10. And this is the summation of all the probability for U and I and so on. Okay. And then we take the log base 2 and we compute. So this is the entropy that we get for only university. Okay. So we could also do for Malaysia and Sabah, and then the higher is the entropy, the more information is captured in that word. Okay. And we have this 3.774. So the higher is the entropy, the more information captured. Okay. So as you can see, if we have is, okay, so the probability of is and s is high. So we will get low number here. Okay, what happen if this is high? We will have log 2 1 kan? So what is log 2 1? Can someone compute? 0 kan? So that means the higher the probability of that symbol, this turn out to be log 2 1, and the whole thing will be expressed as 0. Okay? So that's why when we talk about this, we say this one carry less meaning or less important because they have high probability of their existence in the document. Okay, boleh? Okay, so this formula is simplified to this, and this is the formula of the entropy. Okay, so it says that if the model always assign probability pi to the alphabet symbol si, the entropy can be rewritten as this. Okay, so this is the one that we use when we want to compare the entropy of the attribute in data mining. So this is the simplified formula. This is your exercise lah. Before I forget, your assignment number 3, do you 20th kan? No, your assignment number 3 kan? Or number 5? Yeah. Number 3 and 4 due 20th kan? And your assignment number 5 and 6, 28th of December. Okay, so any other question? Maybe you have question? No? If you okay, can you type number 1? Sikit sejani yang type. So, semua okay, ha? Okay, now we look into the text properties, some of the property of the text that we have. So for the text that we have in the document, we can divide the symbol into this joint subset, symbol that separate the word and symbol that belong to words. Okay. So of course, symbol that separate word, we have the blank space and other symbol, and symbol that belong to word, from A to Z and 0 to 9 lah. Okay. And also we have this zip law, how the different words are distributed inside each document. This law states that the frequency of the most frequent word is given by this. So this is the frequency of the most frequent word, and this is the frequency of the most frequent. Okay, so we are saying that we have F1, and then also we have F2, and we have F3, and ... and we have Fi, and we have Fi plus 1. So we're saying that the most frequent word will be this, okay? And this one will be the most most frequent word. This is the second most frequent word, and so on. So when we talk about the the most frequent word is equal to, we take the most frequent word divided by I, and the alpha is normally 1. Okay. So this is the law, the zip law. Okay, they have proven this one. They said if you want to find the ith most frequent one, we can simply change this one to, we have this one already, and we have this number already. Okay. Okay. There is another angle here. If a text of n words, okay, so we have n words here, and we also have a vocabulary of v words. Okay, so normally the number of n is greater than v, kan? Okay, vocabulary is just the unique word that we have. N is the number of words that we have in the document. Okay, and so the n here, the number of words that we have, should be the summation from I to word that we have, because we have v vocabulary, and this is the frequency of, kalau we tengok this one, kan, this is what, this is the frequency of I, kan. So if we are taking all the vocabulary of that we have in the document, and we count how many times they exist, and we add up all together, we should get the number of words that we have here. Okay. So let me erase this one. Okay, so this is simplified. This is simplified because the whole thing is actually F1, is actually this one. So basically we simplify this one. Okay? And then when we substitute this one, because the Fi is actually this one, so basically they are coming back to the previous formula, which is this one. Okay. So we can get the most frequent word for the first one looking at this one, if we know n lah. Okay. So this is the zip law saying that we can get the number of words based on the frequency of each of the vocabulary that we have. And if we want to find the most frequent one, we can use that one, this formula, in order to get the most frequent word that we have. And the characteristic that we have is something like this, in which this is the frequency and this is the word that we have. So it says that when we are here, we have a small number of words that have high frequency. Okay? When we are here, we have more words that has less frequency, low frequency. So this include what? This include is, the. Okay. So this one has high frequency, but we have a small portion. So it depends on where we want to stop or reduce the number of relevant word in the document. So we could stop here or here to remove all these words from the document that we have. Remember that the more frequent they are in the document, the less information they capture. Okay, so we could slide between these. So this is according to the zip law. For that reason, some of the words yang very frequent, we call it stop word, we remove from the document. That's the reason why we remove them, because based on the information theory, the more frequent they are, the less information they will capture. Okay? So that's proven already in the previous calculation. We also have something like this. When the text size is small, we have small number of vocabulary. But when the text size is big, we have more vocabulary. Means we can build more unique word if we have large number of text size. This is referring to here. So if the text size is large, we could have more vocabulary. Example, this is just out of curiosity. What is the longest English word that you could find? Anyone can name? No? Yes? So I Google, so this is the longest word in dictionary. So I don't think you used this one before. So this is, I don't know how to pronounce Flossie, Nausi, Healy, and something. It's the meaning is the estimation of something as worthless. Okay. Okay. So beside the what we call the information theory, we also look at the text similarity. So we are comparing between text that we have. So there are a few methods on how do we measure the similarity. This is what we call a distance function. So for a string of the same length, we can use the distance function in order to compute the similarity. So the keyword here is this one, same length. Okay. So for example, like this, for this to become this, the distance is 1. From this to this, the distance is 4. So this is what we call the Hamming distance. The Hamming distance referring to what are the number of operations that we could use in order to change this one so that it's similar to this one. Okay, so a distance function should also symmetric, in which the distance between A and C should be less or equal to the distance between A, B plus distance B, C. So if we have A and B and C, so the distance A to B is the same as so this is capital letter A. So C equal to A plus B. So this is the triangle inequality. We also have this edit or Levenstein distance. So the edit or Levenstein distance referring to how many operations or changes that we need to take in order to make two words to be the same. So for example, like this, we add U here in order to make them equal. Either we delete or we add. Okay, and for this one, 2, because we have to replace and also we have to delete R. Okay. We also have this longest common subsequent. This is for all non-common character of 2 or more string. So for example, like this, the longest common subsequence will be survey. So we are looking at only the matching letter that we have. Okay. We could also use this resemblance measure, in which this one will compare the similarity between two documents. So what we want to have is that the resemblance formula here between document I and document J, we wanted to have the intersection between document I and J will be the same as the union of document I and document J. So if these two are the same, the resemblance will be 1. Because if there is no intersection, and the union will be the union between two different documents, we will have 1. Okay? I will show you later on how do we apply this one. And this is the resemblance measure. And we can transform this one into distance function by subtracting the resemblance measurement from 1. Okay, let me show you some example here. So this is our document. And we have unique item in D1, D2, D3, and D4. Okay. So the resemblance measure for D1 and D2 will be, because this is the same. Okay. The formula is we take the intersection between D1 and D2, and then what is the union of these two. Okay. So the intersection will be A, and also we have D. Okay. And the rest none. So that's why we get two intersection. And then the union will be the union of these two. So we have 2 already. 3, 4, 5, 6, 7, 8, 9. So that's how we get 9. Okay. So the rest will be the same, in which we take we count the number of intersection of symbol and divide by the union of those two documents. Okay. So the distance measure we just subtract from 1. So this is useful, but very simple one, because they are looking at the exact matching of the word in each document. Okay. So we also have some exercise here. Okay, lastly, the document pre-processing. We have a few processes that we need to look at. The first one is the lexical analysis of the text, in which we are looking at the format, the structure of the sentence, and then we are looking at the removal of stop word, because we believe that higher frequency of word carry less meaning. We also perform stemming. Stemming is finding the root word of the word that we have. Okay. And then we will gather all these words to become index term or keyword, and then we can construct the term categorization structure or the thesaurus of the document, or the vocabulary of our database. So the first one is lexical analysis, process of converting stream of character into stream of word. So the major objective is looking at the structure and identifying words in the text. So how do we tokenize the sentence? We look at the blank space. Remember just now we say that there are two categories of symbol, one that are not part of the words, and the other one is part of the words. So here we perform the tokenization of the sentence. So we looking at the space, the number, the hyphen, punctuation marks, case of the letter, and so on. So we're looking at the structure. Stop word, I think everyone knows about this. So by removing stop word, we are reducing them by 40%. Just imagine that we could reduce the number of comparison or calculation. Stemming is just to find the root word. So for example, connect will be the root word for connected, connecting, and connection. Keyword selection, just choose the noun words. And these are the whole process that, the standard process that we have. We receive the document, we look at the structure, and this is what we call lexical analysis. We look at the structure of the document, and then we perform the tokenization, and then we remove the stop word, and then we identify the keyword, or we perform the stemming, and then we have the finalized vocabulary. And these are the keywords that we use for what? TF-IDF. This is the word that we use to construct the text document matrix. Okay. Okay. Any question? Semua clear? Sure. Ataupun tidur?